October 13th. You took your test on Friday. We didn't have school on Monday, so it's been a couple days. So take a moment, read the do now and see if you can answer A. So this is a recording. I'm going to go. You might want to pause now, or you can stay along with me, but I'm going to start in 3, 2, 1. Great. So do now says, given the true inequality that -4 is less than 8, state all the positive values of x that would make the inequality below true. Okay. So this inequality true says -4 times x will be less than 8 times x. So can anyone think of a number that I can make x that would make sure that it stays true? Some people say 1. Okay. Does 1 make it true? Let's test it out. -4 times 1, is that less than 8 times 1? We do the math. Is -4 less than 8? Sweet. 1 is the value that makes it true. Anyone think of another number that works? Okay, 2. 2 might work. Let's try it out. -4 times 2. Is that going to be less than 8 times 2? What do you say? All right, yes, it is. Okay. What about 10? Do you think 10 would work? Maybe we're starting to see a pattern here. Does 10 work? Yeah, -40 is definitely less than 80. All right. Maybe we should stop trying numbers, Maybe we could try, I don't know, would 0 work? It's -4 times 0 less than 8 times 0. Ooh, we found one that doesn't work, so 0 doesn't work. Anyone want to throw another idea that doesn't work? Okay, how about -1? Does -1 make this true? Let's try it out. Does -4 times -1, is that less than 8 times -1? So is 4 less than -8? Hey, that didn't work either. How about we try -2? Would -2 work? -4 times -2, is that going to be less than 8 times -2? There's other stuff around here. Sorry about that. And we get 8 is less than -16, and that also is not true. Okay. So does anyone think they can say what does work? Well, maybe we'll say something like that. It seems to be that positive numbers work. I would agree with that. So x looks like it can be greater than 0. If x is greater than 0, so anything above 0, then this is going to be true. Okay. But what I want you to really think about, and you're going to return and talk to a neighbor, is how come negative numbers don't work? Right? So why don't negative numbers make this true? If we put -2 in, why doesn't it work? If we put -1 in. Like, why doesn't negative numbers work here? Right? Why can we only put positive numbers in? Here and here when we multiply. Why can't we put negative numbers in, right? So, well, why can't we put negative numbers? It's a good chance to pause or maybe ask a friend, or if we were in groups who would talk. Well, what happens when we do put negative numbers in, like -1? Why doesn't -1 work? Well, what happens when you multiply a negative by a negative on this side? It becomes positive, right? And what happens when we multiply this +8 by a negative? Well, it makes it negative, right? And so this is no longer true. 4 is not less than -8. So can you try to put it in words? Why don't negative numbers work in this inequality? Stop it from working. And hopefully you said because when you multiply by a negative number, it causes the sides' signs to switch, right? Because a negative, right, like a negative number times a negative number gets us a positive number, right? Switches the sign on that side. And if we do a positive number times a negative number, turns it into a negative on that side. And that's it. By multiplying by negative, it doesn't work because it switches the sign. Okay, that's our big moment for today. Okay, so let's take a moment. You solved some inequalities over the weekend. But right now we're going to jump into 2.3. We're going to talk a little bit more about solving inequalities. Okay, so take a moment, add this to your notes. This is our heading 2.3, solving inequalities. Okay, and something wrong. You can write that down or not. Okay. So we talked about solving inequalities is just like solving equations. That's what's great news. So what I want you to do is take a moment. When I show you, I want you to solve each inequality, doing things to both sides, and then test the solution back in the inequality to make sure that it works. Okay? And I would have you turn in your group and talk to them about it, right? So we should have 4 of these. Yep. Okay, so maybe you want to pause and solve these and test a solution. And then we see if we solve it, do we get the answer that we want? Okay. Good chance to pause. I'm going to start talking about the next step is Zumitaka. Okay. So we solved this one by dividing by 4 on both sides. And our answer seems to see that, here's our solution, that anything greater than 5 would work. Okay. Let's try 6. Does 6 make this true? Things that are greater than 5. Well, let's try it out. Is 4 times 6, is that greater than 20? Is 24 greater than 20? All right. The number 6 work. So that means 7, 8, and that looks like we got our solution. Sweet. All right. Take a look at this next one. X divided by 4 is greater than 20, so we want to know the solution, so we'll solve it by multiplying both sides by 4. Right, we talked about in chapter 1. So we get that x is greater than 80. Okay, so we got to try something greater than 80. I'm going to test 84 because that's a 4, so it might make it easier when we do the division. So I'm going to take 84. Plug it into our inequality. I'll do the math for you. 84 divided by 4 goes in 21 times. Okay. Well, we should have said that was true. Okay. So is 21 greater than 20 if we put 84 in? Yes, it is. So 84 works. So we're good. It's our solution. Things greater than 80 are going to work, like 84. All right. So you would have gone and would invite people up. So if you divide these sides both by -4, just like we're solving equations, you get x is greater than -5. Okay, awesome. Did you check a number greater than -5? I don't know. How about we try 0? Is 0 greater than -5? Yeah, okay. Let's plug it in. Is -4 times 0 going to be greater than 20? Is 0 greater than 20? Yee. 0 is not greater than 20. But we did everything right, but 0 doesn't work. And 0 is greater than -5. This doesn't seem to, this is like the wrong solution, it seems like. All right, let's jump to the next one too, right? So let's multiply both sides by -4 to solve it. Then we got negative, oh, sorry, these cancel. We get x is greater than negative 80. I don't know. Let's try a number like 4. 4 is greater than negative 80, so I'll just throw it in there and see. So is 4 greater than negative 4? 4 divided by negative 4, is that greater than 20? You get negative 1. Negative 1 is greater than 20. No, it doesn't work. That's not right. So another wrong solution. Shoot. Okay. If we solve these two, like we normally do, we get solutions, and we tested one, and they work. But on these two, when we solved them normally, it didn't work. We don't have our answers. So this is where it makes something's wrong here, right? And hopefully you've thought about it, or maybe you've seen it before in other grades. It's what we did to both sides that caused the problem. Because things greater than negative 5 don't work. And things greater than negative 80 on this one don't work. But because of what we did, what we chose to do to both sides, it actually gave us a false solution. So a real solution should be in this first one, not things that are greater than negative 5, but we actually need things less than negative 5. And in this one, where we wanted it greater than negative 80, we actually find that all the answers less than negative 80 is our answer. And it's because when you solve inequalities, hopefully you've guessed it from the initial one, it's these negatives that we did that cause the signs to mess up. So, here you go. Solving equations and solving inequalities. There's only one difference you have to remember. It's the only thing. It's the only difference, okay? And it's a little bit long, but it's worth writing down. If you divide and or multiply, I should say probably or. If you divide or multiply by a negative on both sides of an inequality, you need to reverse the inequality sign to make the solution true. Okay? It's the only difference. Boom. We solve it just the same way, doing things both sides, but if we ever divide or multiply by a negative on both sides of an inequality, you need to reverse the inequality sign. Okay, so that makes chapter 2 kind of great because it's the only thing that's different. So I'll give you an example. Take a look at this first one. We want to solve for x, find all the things that work. So I'm going to divide both sides by negative 10. And then you get x is greater than negative 2. Okay? But I want to circle that, add it to your notes. I divided both sides by negative 10. Okay, because I did that, this is a false solution. Okay, so what we're going to do to resolve it, which is nice, and because of the negative stuff, we're just going to flip it. We're going to say x, none of these numbers work, but it's actually the less than negative 2. And the flip of the inequality sign causes this to be right. So if you tried anything less than negative 10, negative 2, you would work now. Okay, and we're going to cross this one out. And just to show you once, now that you're on video and you can just watch, let's try something less than negative 2. I don't know. Let's try negative 3. So I'll plug negative 3 into here. We get negative 10 times negative 3. Is that going to be greater than 20? Is 30 greater than 20? Sweet! It worked. this is not the answer. This is the answer because we divided both sides by a negative 10. Okay, let's take another example. We have 10x is greater than negative 20. We're going to get x by itself by dividing by 10 on both sides. The 10 divided by 10 cancels, so we get x is greater than negative 2. Okay, but we had a negative, so we're going to have to flip the sign. Except, maybe you caught it. Did I divide both sides by a negative number? No, I chose to divide stuff by 10. So this is actually the real answer, not this one. No flip. Okay, we're not flipping the sign. We decided to divide by 10. That's cool. Our answers are going to work. Everything greater than negative 2 will work. You can test it out. Try 0. So 10 times 0, is that greater than negative 20? Well, is 0 greater than negative 20? Yes, yes, yes. So it works. So we didn't need to flip the sign. Okay. I guess we talked about that? I guess we do. Let's see. Oh, okay. And just a quick thing that students kind of get stuck with. So last one here. So we have negative x over 5 divided by 2. Okay, but that negative sign is between the x and the 5. Do you see it? So my question is, what's really negative? Is the x negative? Is the 5 supposed to be negative? Like, where should that negative sign go? Or should we just leave it out front? And then how do we handle it, right? And I would ask people, do you know where it goes? It can go here. Or you could move it up to make the x negative. Fine by me. Or in this case, you might want to make it where the x is positive, but we move it down to the negative. These are all the same. In the middle negative, up top negative, down bottom negative. But notice there's only one negative sign. We don't have 2 anywhere. All right. I think this one makes the most sense to use right now, this form, because I can solve it by multiplying both sides by negative 5. Cancels, x is greater than negative 10. But that's going to cause a sign flip because I multiplied by negative 5. So that's not answer, fake answer. Our real answer is x is at less than negative 10. Boom. This is your real one. I move that. Fake answer. Yeah, I don't like where that is. Okay, cool. So we run into this today. It can go up, it can go down. You want to move it wherever the number is. That's really it. Okay, so classwork today is on page 115, 18 through 40, and page 118, numbers 1 through 6. And it's also to finish for homework. So I'll post it. If you have questions, just jump on Google Classroom and we can talk more about it. But here it is. I'll attach the page numbers with the questions. Make sure you show your work. Make sure you show your steps and watch for the sign flip. Okay. All right. I'll talk to you tomorrow.